Today I am talking about how do you scale Opentelemetry collectors using Kafka. To introduce myself, I am Pranay. I am one of the founders and maintainers at Signoz. I've been working as product manager in the past. I was product manager at Microsoft and multiple other startups. In my past time, I love reading and taking a walk in the nature. Just to set context, why I'm talking about Opentelemetry collector. So, as I mentioned, I am maintainer at signoz. It is an open source observability platform. We have been there around for 3 years. We have around 16,000, 70,000 GitHub stars, 4,000 plus members in Slack community, 130 plus contributors. And it's Opentelemetry native single pane in glass for observability. So we have support for different traces, metrics, and logs, and you can see all of them in a single pane and correlate across them. And today I'll be talking about our experience with Signoz Cloud, and underneath we use Opentelemetry collector and how we scaled it and our experience regarding that. So that's where I'm coming from. Just to set context for people who are not aware, what is Opentelemetry? So Opentelemetry is a CNCF project. It's a vendor neutral standard for sending telemetry data from your applications, and it supports all the signals. So you can send metrics using it, you can send traces using it, you can send logs using it, and this is sort of becoming now the default standard for how people do observability. This has helped, and so why is it important? So Opentelemetry is the second fastest growing project in CNCF, and this is just after Kubernetes, so you can understand how popular it is. What it enables is it enables sending data to any backend. So it standardizes on the telemetry protocol through which you send data, or applications can send data, infrastructure can send data to a backend. This is now becoming the default standard for instrumentation, and people can use any backend which supports Opentelemetry for their use cases. The big advantage it gives is that users are now not getting vendor locked in to a particular ecosystem, and hence have more flexibility. So this has promoted a lot of innovation in the ecosystem. The other key advantage is that it has been a unique standard where, in the sense that it supports all the three signals, metrics, traces, and logs from get-go, and also new signals like profiling is in progress. And at Signoz, we are natively based on Opentelemetry. When we started the project in 2021, we took a bet on just being natively based on Opentelemetry. That's the only SDK we support. And most of the things we do, we try to rely on Opentelemetry as much as possible. So today in our talk, we'll talk about if you have used Opentelemetry collectors or have tried it for setting up your observability, how you can scale it and use it for like huge scale. And I'll talk about our context on how we leveraged it for a Signoz Cloud product, and hopefully it will be helpful for you to get a sense of where things are. Cool. So now we understand what Opentelemetry is. One of the key components of Opentelemetry is the Opentelemetry collector. You can think of it essentially as a pipeline through which you can send data, process data, and send to different destinations, right? So there are three key components of Opentelemetry collector. There are receivers, there is a processor, and then there are exporters. So through receivers, you can receive data from different formats. For example, you have host metric receiver, which can receive data from machines and infrastructure metrics like CPU users, memory users. There's a Kafka metric receiver where you can get metrics from Kafka. And there are like 90 plus such receivers which enable you to receive data from different sources. The next is processors, which basically helps you do different type of processing. So you can do change attributes, you can do filtering of particular type of logs, traces, or metrics, and then you export it to new destinations. So you can export it to destinations like ClickHouse. You can export it to backend providers like signoz, or you can use any other exporter like Kafka exporter to send data across via Kafka. So OpenTelemetry collectors are really the key components in OpenTelemetry, and we'll focus on how we have used OpenTelemetry collectors to provide this our signoz cloud service. Just to take you a bit deeper into our signoz cloud for the single tenant architecture. So this is without Kafka. We have both multi-tenant and single-tenant architecture. In this talk, I'll primarily focus on the single-tenant architecture because that's where we have used Kafka a lot to scale this architecture. So imagine there's a customer who is using OTel collector as an agent and sending data to signoz backend, or they're sending directly data through applications, right? So in architecture which doesn't involve Kafka, they will send data directly to a load balancer, and then there will be then directed to the individual tenant OTel collectors. So in this architecture, signoz tenant has their own OTel collector. The load balancer points to sends data from a particular customer to their specific signoz OTel collector, right? The problem with this architecture is that if the tenants go down or the DBs in this tenant have issues, then the agents start, the OTel collector here starts giving 5xx. That leads to loss of data, right? Also, if the tenant has to, if a customer suddenly has spiked their ingestion rate, so say they have made it 10x it in say few minutes, this leads to, if it is directly connected to a single OTel collector, maybe the OTel collector doesn't scale as quickly, and that may lead to loss of data for the tenants, right? So there's always some time which the tenant DB takes to scale up, and during that time there will be loss of data for the tenant. So effectively, customers may see some data getting dropped, which is obviously not a good thing, right? So yeah, this were some of the problems which we immediately identified with a single tenant architecture. It seemed imperative that there should be a queuing system in front of the after the gateway OTel collectors, right? So in this example, here is the load balancer. So the load balancers, so the signoz customers send data to the signoz load balancer, and then that talks to a gateway of collectors. So this is basically a fleet of horizontally scaling which receive data from the customers. We use something called a Kafka exporter. So as I mentioned earlier, OTel collector has something called exporter and a receiver and processor. So in this example, we are showing OTel collectors, gateway OTel collectors. They receive the data from and then we use Kafka exporter in the OTel collector to send data to Kafka. So we have a Kafka setup here. I'll get into more details on what is the setup and the configuration for that. And then in the signoz tenant, which also has a OTel collector in it, we enable the Kafka receiver and get data from Kafka there. So as you can see here, sort of, even if there is a huge spike in load from a particular customer, the Kafka acts as the queuing system in between to absorb that spike, and then as the tenant system OTel collector gets scales up, it can start consuming at a higher rate. So there's no loss of packet drops, which we had earlier where there was no Kafka in place. Yeah, so these are some of the use cases where Kafka can be helpful. So this enables a highly available ingestion. So this is our current Kafka setup. We have 6 hours retention period, replication factor of 3, and then a 10 MB max message size, right? So Kafka, as you know, is we have configured it to be highly available, so with a reflection factor of 3. So Kafka acts as a buffer for 6 hours. It has much higher availability. It can handle busty traffic. Tenant can continue consuming at their rate and have some time to scale up as they need, while the Kafka acts as sort of the single line of defense against a very high spike in loads. These are the two key main factors. But one of the parallel advantages to this is that this can also enable a lot of additional processing, which we can do at Kafka. For example, especially in the case of tail-based sampling for traces, sometimes people want to filter traces by trace ID and accumulate all traces at one place and then do some processing on it. For example, if you want to reject or like not store traces which has particular attribute in it, for example, say if you want to reject all traces which have health check endpoints, right, which essentially don't add value. In case if there are just hotel collectors, you would have to you'll have a challenge of like having all hotel collectors, in the case where there are like multiple hotel collectors, to like all spans come to the same hotel collector, right? Because hotel collector by its nature is horizontally scalable, so you don't really control which hotel collector which span will go to, and they are stateless. In Kafka, this problem can be solved much easily because you can use trace ID as a partition key, and that would enable all trace IDs to go to a particular, and hence you can do all those trace tail-based sampling much easily there. So having a queue system in between helps you doing a lot of additional processing, especially if you want to do tail sampling at the hotel collector level, much easier, right? So as I said, this is our Kafka setup. So just to give an example, these are some of the typical things we monitor. So if you have set up Kafka, you will also need to monitor like how many records are getting produced, what's the, for each tenant, what's the sort of difference, how much records are getting consumed. So the difference between the number of records produced and consumed basically tells you like what you need to do. Is there a lag in between, if you need to scale your system or not, right? So when you set up our system here with Kafka, we actively monitor all these metrics, and as you can see, we use signoz to monitor signoz. So this is a case of the monitor getting monitored itself, and we use signoz internally heavily to monitor all our SaaS customers and use cases. So you can monitor all different types of Kafka queues here, how many records are being consumed, how many records are being generated. Monitoring consumer lag is very important. So this gives you a sense of like, hey, like how much ingestion is there and how much is the individual hotel collector is consuming, right? For example, in this case, as you can see, like for example, a particular customer starts sending in data at a very high rate, and this like the tenant for that is consuming a particular rate, right? So if the ingestion rate suddenly spikes, then this the consumer lag here will increase, and that we monitor actively to throw alerts and so act as a signal that, hey, like maybe the signoz tenant needs to be automatically scaled, and like we need to add more resources there. So this scaling happens automatically, but consumer lag is like one of the pointers which helps you decide what to and when to scale the tenants, right? So we monitor all this active like consumer lag actively, and what are the number of Kafka clusters. So we use Redpanda internally to monitor all this. So how many are the Redpanda brokers? What is the consumer lag which is there in between? One of the key factors which we use for scaling is to scale based on consumer lag. So how many partitions to increase or not. And then this can also be used as a metric to scale up your consumer group, right? So and tenant. So if you see the number of, like the consumer lag is increasing a lot, we write scripts to automatically scale this up, basically enable higher ingestion, like higher consumptions from the hotel collector, tenant hotel collectors, and that reduces the consumer lag, and basically the systems gets stable again. So Kafka acts as a buffer in between to handle workloads. In the scenario, if there was no Kafka, as we had discussed earlier, then suddenly this hotel collector will get overwhelmed, and if it doesn't scale at the same rate, then it will start dropping packets. If Kafka is present, then that doesn't happen. So consumer lag is an important thing to monitor. That helps you scale Kafka. Also, one thing which I actively monitor is consumer latency. So what is the producer consumer latency? So here, if you see, we have plotted how much time it takes for the producer to produce and get into Kafka, and what is the latency which like the consumer has. And if this latency increases by a particular amount, we throw out alerts and signals, and that basically indicates that, hey, there is something wrong, and then maybe some steps needs to be taken to fix it, right? So till now, the Kafka-based architecture is working quite well for us. It enables very fast ingestion. It can handle spikes in loads from workload customers, and data is retained for 6 hours, and that works. We even get a huge compression factor of 10 to 15 because hotel collector by default works in a batch model. So it sends data in batches, and before ingestion into Kafka, we are able to get a huge compression before sending that. So in that sense also it works quite well, and it handles spikes, as I mentioned earlier, also very well. There are a few areas where I think there could be improvements which we are working on currently. So can we make this automatic increase of based on just on the scale of ingestion of a topic? If a partition gets stuck for a tenant hotel collector, then can we use some methods like dead letter queue to drop after a few retries so that it doesn't get stuck in a permanent failure? Also making the whole tenant hotel collector, which is like Kafka receiver to processors to exporter, a synchronous module so that consumer commits an offset only after the message is successfully returned to a DB. So there's some guarantee on when the message is being written. And the other key piece is like, hey, can we make this exactly once delivery, which as you know, in a queuing process is not easy to do, right? So these are some of the improvements which we foresee in the future and which we're working on to solve. But overall, just adding Kafka on the hotel collector has been a step improvement for us, and hopefully for other people, other teams which are running this at scale, they can take this as a guide. And so yeah, that's all I had for my talk. Just want to give a shout out for signoz. So we are a actively growing community in using Opentelemetry, and we are a complete observability stack. So you can check out our signoz repo. If you try it out, feel free to create an issue or participate in our Slack community. As I mentioned, we are a quite active Slack community where you can come and get your questions answered. And if you have any follow-on thoughts with me, feel free to email me, or that's all from my side. Looking forward to hear more from you, and feel free to reach out to us if you have any feedback. Thank you.